Dear students, today I am going to discuss about a new topic called simulation. In this lecture, I am going to explain how to use your Excel for doing the simulation. I have taken one example. The example is introduction of a new product. So, the example says if you are introducing a new product, what is the probability of success? This is a very common problem for a business. So, this problem we are going to solve with the help of Excel. The agenda for this lecture is, first I will introduce what is the simulation, some basic concepts, some of very common applications. After that, I will explain the concept of risk analysis, where what is the risk here is that if company introducing a new product, what is the possibility of success? How much risk is there for launching a or introducing a new product? That is an example which we are going to solve in this lecture. First, we will explain what is simulation. So, simulation is one of the most widely used quantitative approaches to decision making. It is a method of learning about real system by experimenting with the model that represents the system. So, we are going to consider a model, that model will represent the real system. A simulation model contains a mathematical expression and logical relationship that describes how to compute the value of outputs given the value of the inputs. So, we are going to consider a mathematical model, because model can be in any form. It may be a geometrical modeling also, but here we are going to consider mathematical model. The inputs for the simulation model can be classified into two categories. One is controllable inputs and uncontrollable inputs. So, uncontrollable inputs can be either uncertain or known with the certainty. The later part of the lecture I will explain what is this controllable, uncontrollable input. If I look at this picture, you see there is a right hand side, there is output, there are controllable inputs. Controllable input is the decision which you are going to take. Suppose launching a new product, it has to be launched or not, okay, that is a controllable inputs. So, launching of the new products, there are many variables which are not in your hand, that may be certain or uncertain. If it is certain, there is no problem, but if it is uncertain, that is the case where we need the concept of simulation. If the inputs are uncertain, how that is going to affect our output? Okay. That is the purpose of this lecture. How simulation works? In conducting a simulation experiment, an analyst selects the value or values for the controllable inputs and sets the certain uncontrollable inputs to the known values. Okay. So, here we know the controllable inputs and we are going to assume that values for uncontrollable inputs. Then the value of uncertain inputs are randomly generated. Here these uncertain inputs, it may follow any distributions. It may be empirical, it may be uniform, it may be normal distribution. So, randomly generated from analyst specified distribution. So, we need to know in advance this input follow what kind of distribution, whether it is uniform, whether it is normal. The simulation model uses these controllable inputs and the value of uncertain inputs to compute the values of the output. So, the simulation model will use this uncertain inputs to get the values. By conducting a series of experiments using a variety of values for controllable inputs, the analyst learn how values of controllable inputs affect or change the output of the simulation model. So, we are going to see how these controllable inputs, okay, is going to affect the output of the model. After reviewing the simulation result, the analyst is often able to make decision recommendations for the controllable inputs that will provide the desired output for the real system. So, we will be considering various inputs. So, for what range of inputs we are getting the best output. So, that controllable input is our solution for the simulation. So, the objective of this simulation is to determine the probability that the new product will be profitable or not. So, here we are going to consider this example, new product development. So, we are going to see the probability of success. A model is developed that relates profit to various, the profit is here output measures, to various uncertain inputs such as demand, part cost and labor cost. So, in this example we are going to consider 3 uncertain inputs. It may be demand of that product. Obviously, demand cannot be fixed. The value of demand we may not know in advance. And then there is a variability of the part cost, say material cost, and there is a variability in the labor cost. So, these are the 3 inputs. Okay. The only controllable input is whether to introduce the product or not. Here, this decision of whether we should introduce the product or not, that is our controllable inputs. What are the uncontrollable inputs? Demand, part cost and labor cost. So, a variety of possible values will be generated for the uncertain inputs, that is our demand, part cost, labor cost, and the resulting profit will be computed. Like this, there are so many applications of simulation. Another application of simulation is airline overbooking. You might have seen the ticket fare, sometime it is higher, sometime it is lower. So, there they use the concept of simulation. How they use? So, the objective of this airline simulation is to determine the number of reservations an airline should accept for a particular flight. A simulation model is developed that relates the profit for the flight to an uncertain input and the number of passengers with the reservation who show up and use their reservation, and a controllable input is the number of reservation accepted for the flight. For each selected value of controllable inputs, a variety of possible values will be generated for the number of passengers who show up, and the resulting profit can be computed. This similar type of model, simulation models are applicable for hotel, car rental reservation systems. This is our second application. So, third application is inventory policy. We will be solving this problem also, inventory policy. The objective of this simulation is to choose inventory policy that will provide a good customer service at a reasonable cost. In the previous lecture, we have studied different inventory policies. Whenever the demand is probabilistic in nature, then we can use the concept of inventory for simulation. A model is developed that relates 2 output measures. What are they? Total inventory cost and service level to uncertain inputs such as product demand and delivery lead time from vendors, controllable inputs such as order quantity and reorder points. So, for each setting of controllable inputs, a variety of possible values would be generated for uncertain inputs, and then resulting cost and service levels would be computed. So, here the output of the model is cost, service level. What are the inputs? We can say product demand, delivery lead time. Okay. So, here we can say these are the uncontrollable inputs. What are they? Product demand and delivery lead time. What is the controllable inputs? What should be the order quantity and reorder level? Quantity to be ordered and reorder levels are controllable inputs. What are the uncontrollable inputs? Which are which are not in the hand of the decision maker. One is the product demand, okay. Here I am writing demand, another one is lead time. Okay. This is an inventory policy. Another application of simulation is traffic flow. Here the objective of this simulation is to determine how installing a left turn signal will affect the flow of traffic through a busy intersection. A model is developed that relates waiting time for vehicles to get through the intersection to probabilistic inputs such as number of vehicles arrivals and the fraction that they want to make left turn, the controllable inputs such as the length of the time to the left turn signal is on. So, here okay, here the input is, here also we can consider controllable inputs and uncontrollable inputs. What are the controllable inputs? Length of the time, for the left turn. What is the uncontrollable input? Waiting time. Okay. These are probabilistic input. What is the output? The traffic, the flow of traffic. Flow of traffic. So, what will happen when the length of the left turn signal duration is high? What will happen? The flow will be high, the flow of the traffic will be high, so, because there will not be any much traffic. For the purpose of analyzing the traffic, we can use simulation. Another common example is waiting line. Here we will be, after some lectures we will be studying this waiting line example also. The objective of this simulation is to determine the waiting time for customers requesting service from a facility such as customer phoning a call center. A model is developed that relates customer waiting time to uncertain inputs such as customer arrivals and service times, controllable inputs such as number of server. For each value of controllable inputs, a variety of values would be generated for uncertain inputs and the customer waiting time would be completed. This information on the impact of number of call center agents on customer waiting times can be then used in capacity planning decision for call center. So, here what we can see, this is a simulation model. Here we can see controllable inputs, uncontrollable inputs, this is the output. What are the uncertain inputs? Customer waiting time. Waiting time. Then our the customer arrival pattern, these are uncontrollable inputs. What is the controllable inputs? Call center agents, number of call center agents. What will be the performance measures of this model? The waiting time. Waiting time. What will happen? If you have more number of call centers, call agents, the waiting time of the customer can be decreased, because the customer need not wait for longer time. People will not wait also, they will go to some other services. So, for waiting line applications also we can use simulation. We will be taking one example here for this waiting line problem also, then we will solve with the help of Excel. The another important point is simulation versus optimization techniques. Many time people have a confusion whether a result which we are getting out of simulation is an optimized solution or not. Here the point is simulation is not optimization technique. because in every trial you may get different results. So, you may not get the optimized values here. So, simulation is a method that can be used to describe or predict how system will operate given certain choices for the controllable inputs and randomly generated values for uncertain inputs. So, analysts often use simulation to determine value of controllable inputs that are likely to lead desirable system output. In this sense, simulation can be an effective tool in designing a system to provide good performance. In a waiting line example, what is a good performance? So, we should not ask the customer to wait say more than 2 minutes or 1 minute. That is our good performance, because in a call center if customer is calling, he may not be willing to wait. So, here the example which I am taken in this class is risk analysis. What is risk analysis? Risk analysis is the process of predicting the outcome of decision in the face of uncertainty. In this lecture, we describe the problem that involves considerable uncertainty, that is the development of a new product. We first show how risk analysis can be conducted without using simulation. Then we show how more comprehensive risk analysis can be conducted with the aid of simulation. So, first we will go to doing the risk analysis without simulation. So, I have taken one hypothetical example. This example is taken from this reference book Anderson et al. A company is producing a portable printer. The selling price is $249 per unit. Administrative cost is $400,000. Advertising cost is $600,000. What are the probabilistic input? Direct labor cost. Labor cost is $45 per unit, but it may vary. Another probabilistic input is part cost, $90 per unit, but it may vary. Another probabilistic input is the first year demand. Demand is 1500 units. First we will do what if analysis. So, we can write an equation for a profit. What is the profit? Selling price, that is over 249 minus direct labor cost minus part cost per unit, the direct labor cost also per unit. The $249 is profit per unit. So, that will provide you the selling price minus cost profit per unit. Then you multiply it by demand, that will give you the overall profit. Then you have to subtract these other expenditures, overhead expenditures. So, that is over $100,000. The expression for profit is 249 minus labor cost minus part cost multiplied by demand minus overall overhead expenditure, that is advertising cost and administrative cost. Now, first we will explain into the profit. What is this model? You see, the controllable input is introducing new products. Okay, this is your controllable input. What is the uncontrollable inputs and the probabilistic in nature? Labor cost, part cost and first year demand. So, the profit function can be written as 249 minus C1 minus C2 multiplied by demand minus your overhead expenditure. So, that will give you your profit. So, what we are going to learn from this model is what will be the best case and worst case, because we are not going to talk about simulation now. First we will do without simulation. So, we are what are the uncertain inputs here? Labor cost, part cost and the first year demand. First we will go for base case scenario. So, the best estimate for the direct labor cost per unit, the part cost per unit, that is C1 and C2 and X, that is demand, is $45 to $90 and 15,000 units. So, in the base case scenario, what will be the profit? 249 minus 49 minus 90 multiplied by demand minus 10 lakh. So, you will be getting $7,10,000. That is your base case scenario. Then we will go for worst case and best case. What is the worst case? The worst case is the highest possible value of your C1 is 49, the highest value of your part cost is 100 and the lowest demand, that is our worst case. So, when you substitute these values, how we are getting 47 and 100. So, this was provided the highest value of labor cost, highest value of part cost and the lowest value of the demand. So, when you substitute, you are getting 8,47,000 is the loss. The best case is, because it is a cost, lowest value of your labor cost, lowest value of part cost and the highest value of the demand, this also provided to you. So, in that case you will be getting 25,91,000 as the your profit. So, the lower limit of the profit at the worst case is 8,47,000 loss and the best case is 25,91,000. So, at this point the what if analysis provide the conclusion that the profit can range from loss of 8,47,000 to the profit of 25,91,000 with the base case of 7,10,000. Although the base case profit of 7,10,000 is possible, the what if analysis indicate that either a substantial loss or substantial profit is possible. So, other scenario that the company might want to consider can also be evaluated. So, there may be different values, because we have seen the extreme values of C1, C2 and X. So, in between these extreme values there are different combinations are possible. Okay. However, the difficulty with the what if analysis is that it does not indicate likelihood of various profit and loss values, because we consider only the fixed values. In particular, we do not know anything about the probability of loss. Using simulation to perform risk analysis for the company is like playing out many what if scenario by randomly generating values for uncertain inputs. So, here there are 3 C1, C2 and X. Okay. So, if we can substitute different values of C1, C2 and X, then we can get different scenarios. So, the advantage of simulation is that it allows us to assess the probability of a profit and probability of loss. Using the what if approach to risk analysis, we selected the values for uncertain inputs. What are they? Labor cost, part cost and first year demand, then computed the resulting profit. Applying simulation to the company's project require generating values for the uncertain inputs that are representative of what we might observe in practice. What is the meaning of representatives? These C1, C2 and X should affect our profit. That is, sometimes there are some inputs that may not affect our profit. Okay. To generate such values, we must know the probability distribution for each uncertain input. Further analysis led to the following probability distribution for direct labor cost, the part cost per unit and the first year demand. So, what are the probability? So, the labor cost follow empirical distribution, right. There is a 40% chance the labor cost may be $45. This is C1. For C2, uniform distribution, part cost which follow uniform distribution. The lowest value is 80, highest value is 100. The probability is 1 upon 20. And the third one, the first year demand follow normal distribution. The mean of the normal distribution is 15,000 and standard deviation of normal distribution is 4,500. 500. So, we are going to use these 3 inputs to generate the profit. Then working procedure for simulation. To simulate the company's project, we must generate values for 3 uncertain inputs and compute the resulting profit. Then we generate another set of values for uncertain inputs and compute a second value of profit, and so on. So, we continue this process until we are satisfied with enough trials. Here enough trial is number of iterations. Enough trials have been conducted to describe the probability distribution of a profit. This process of generating uncertain inputs and computing the value of output is called simulation. That simulation process I have explained in the form of flow chart. So, this picture is sequence of logical and mathematical operations required to conduct a simulation. Okay. First, what are the model parameter? Parameter means which you will not change: selling price, administrative cost and advertising cost. What is the probabilistic input, uncertain input? One is labor cost, part cost, first year demand. Then there is a profit function, we will substitute there. So, here x is the demand. So, when you substitute here, you will get one profit. Then we will go to the trial 2, trial 3, trial 4, trial 4. So, we will be getting maybe here we are going to make 500 scenarios, 500 iterations of this profit. So, that we are going to plot it. So, output measures of interest. At the end of the simulation, output measures of interest can be developed. For example, we will be interested in computing the average profit and the probability of loss. Here probability of loss, we are saying the risk of getting into loss when we launch a new product. For the output measures to be meaningful, the values of the uncertain input must be representative of what is likely to happen when the company's printer is introduced into the market. As I told you previously, this output measures should directly affected by the input. There are sometimes some inputs that may not directly affect your output measures, but we have to consider only the inputs which are directly affecting the output. An essential part of simulation process is the ability to generate representative values of uncertain inputs. So, that we will be doing the uncertain inputs. Because random numbers are equally likely, so quantitative analysis can be assigned range of random numbers to corresponding values of uncertain inputs, so that the probability of any input value to the simulation model is identical to the probability of its occurrence in the real system. The whole simulation, we are going to use the concept of called random numbers, but many software packages which provides random numbers, that random numbers are called pseudo random numbers. So, what will happen? The random numbers which follow uniform distributions, okay, these are random numbers. This will be in between 0 to 1. For example, in Excel there is a function called rand. So, here you will get the random numbers between 0 to 1, but there is another function rand between. So, if I write 20, 30, I will get a random number between 20 to 30. This is the pseudo random number. The random number which you are generated from calculator is called a simple random numbers. Okay. So, the random numbers will follow uniform distribution. So, the probability of any number between 0 to 1 is same. This is probability. Here x. So, random numbers and generating uncertain input values. In the company simulation problem, the representative values must be generated for direct labor cost C1, part cost C2 and the first year demand. Random numbers and the probability distribution associated with each uncertain inputs are used to generate the representative values. To illustrate how to generate these values, we need to introduce the concept of computer generated random numbers. So, the computer generated random numbers are randomly selected numbers between 0 but not including 1. All the values of computer generated random numbers are equally likely and so uniformly distributed over the interval 0 to 1. So, computer generated random numbers can be obtained using built-in functions available in computer simulation packages and spreadsheets. For instance, placing rand in a cell of an Excel worksheet will result a random number between 0 and 1. Okay. There are, in the previously I was saying, there are certain computer generated random numbers, that random numbers called pseudo random numbers, that won't be 0 to 1. For example, I want to have a random numbers which follow normal distribution, say mean 100, standard deviation say 20, I may get set of values. So, that values are called pseudo random numbers. But if you are getting computer random numbers between 0 to 1, that is your ordinary random number which follow uniform distribution. So, this is an example. I have generated 500 random numbers with the help of this rand function. You see that all the values are between 0 to 1, but 1 will not be there. Okay. The 500 random numbers generated using Excel. So, these numbers can be viewed as a random sample of 500 values from a uniform probability distribution over the interval from 0 to 1. Let us show how random numbers can be used to generate values of companies' probability distributions. So, we begin by showing how to generate a value for direct labor cost per unit. This approach described is applicable for generating values of any discrete probability distribution. Now, I will explain how to use Excel for generating random numbers. As I told you, for example, if I keep my cursor here, see that if I type equal to rand and you close the bracket, I got a random numbers 0.9450. I can drag it. Okay. So, this is the random numbers between 0 to 1. If I press F9, you see that the value of random numbers are getting updated. In your keyboard, if you press F9, the value of random numbers are getting updated. Like this, at the bottom I have generated 500 random numbers. You see that generated 500 random numbers. In Excel, there is another function called rand between. So, that says say equal to rand. See that rand between, if I type say 20 comma say 50, see that I can drag it, this also I can drag it. Can drag it. Then if I press F9, you see that your random numbers are getting updated. So, this rand between is a function to generate random numbers between say for example 20 and 50. The rand function is to generate random numbers between 0 to 1. These numbers can be viewed as a random sample of 500 values from a uniform probability distribution over the interval 0 to 1. These numbers, it follow uniform distributions between 0 and 1. In the next lecture, I will show how random numbers can be used to generate the values of the problem which we are discussing now, that is the portable printer, how to these inputs for the problem can be generated with the help of probability distributions. Dear students, in this lecture I have introduced the concept of simulation, then I have explained various applications of simulation. Then in the simulation model I have classified the input into two categories, one is controllable inputs, another one is uncontrollable inputs. Then I have taken a sample problem of introduction of the new product and what is the risk of introducing the new product with the help of base case, worst case and best case what if analysis. After that I have explained how to generate random numbers with the help of Excel. In the next lecture, we will continue the problem what we have discussed and we can solve that problem with the help of Excel. Thank you very much.